Assalamualaikum. Okay, next we go for the noble gases. Okay, so as you know, noble gases located on group 18, for example, helium, neon, argon, krypton, xenon, and radon. Okay, so it has complete outer energy level where the electron is fully filled. So it cannot obtain or gain any electrons. Okay, so that's why the noble gases are not reactive and cannot form bonding with another atom. Okay, so for the stability of the noble gases, okay, it has octet 8 electron in its valence shell. Therefore, the noble gases are inert and not able to take part in any chemical reaction. Okay, for general chemical reaction, okay, an atom must achieve octet or noble gas configuration by transfer valence electron or sharing a pair of electron. Okay, so it can form a bonding from atom. For the octet rule and its exception, okay, octet rule state that atoms tend to gain or lose electron until it have 8 electron in the valence shell to form stable compound. Okay, so octet must be ending with S2P6. Okay, for example, neon, okay, it has 10 electron. So when you put the electron configuration 1s2 to s2 to p6. Okay, so the outermost shell contain 2 plus 6 electron, okay, for electron valence. So it has octet, okay, when achieve 8 electron. Okay, the exception to the octet rule, okay, it has 3 types. First, odd number of electrons. Second, less than octet. Okay, third, more than 8 valence electron or expanded octet. Okay, for odd number of electron, so usually rare, unstable, and for example, this molecule. Okay, when you look at the nitrogen, so it not achieve octet, only 1, 2, 3, 4, 5, 6, 7. Okay, so the type is odd number of electron. Okay, second type is less than octet. Okay, example, molecule boron trifluoride. Okay, so okay, this is the structure of boron trifluoride. Okay, so around the central atom, so you can see there are 2, 4, 6 electron around the boron. Okay, so not achieve octet. Okay, only 6 electron around boron. Okay, so this is type less than octet. Okay, for this example. Next example, more than 8 valence electron. Okay, or expanded octet. Okay, so this is applied to the element located on period 3 or third row and below. Okay, so it has more than 8 valence electron or expanded octet because the empty d orbital used to accommodate additional electron. Okay, so for example, phosphorus and sulfur, or there's element located on period 3 and above. Okay, so example for phosphorus. Okay, so around phosphorus, it can accommodate more than 8 electron. Okay, here we can look, there's 10 here. Okay, more than octet. Okay, for sulfur also 2, 4, 6, 8, 10, 12. Okay, because of using empty d orbital to accommodate electrons. So this is under type expanded octet. Okay, more than octet. Next, we go for intermolecular forces. Okay, so there are two types of forces. First is intermolecular forces. Second is intramolecular forces. For intermolecular forces, okay, the forces exist between the molecules. Okay, and it will influence the physical properties of the substance. Okay, example of intermolecular forces are hydrogen bond, London dispersion forces, and dipole-dipole forces. Okay, this intermolecular forces is weaker, okay, when compared to the intramolecular forces. Okay, for intramolecular forces, the forces exist within the molecules, okay, and it will influence the chemical properties of the substance, such as the forces are ionic bond and covalent bond. For intramolecular forces, it much stronger, okay, compared to intermolecular forces. Okay, intramolecular forces, okay, so the forces exist within the molecule. Okay, dalam molekul tu antara force that exists between the atom in a molecule. Okay, if intermolecular forces, okay, the forces exist between the molecule of H2O. Contoh, okay, antara molekul H2O adalah intermolecular forces. Okay, so for example, 41 kilojoule need to vaporize 1 mole of water for intermolecular forces. Okay, but 930 kilojoule to break all the bonding between oxygen, hydrogen in 1 mole of water. So to break the bond, intramolecular forces, high energy needed, okay, compared to intermolecular forces. So the intermolecular forces, example is London dispersion forces, hydrogen bond, and dipole-dipole forces. Okay, so among these three intermolecular forces, hydrogen bond are the strongest, okay, compared to dipole-dipole forces. Okay, dipole-dipole forces stronger than London dispersion forces. Okay, so London dispersion forces is the weakest compared to dipole-dipole forces and hydrogen bond. Okay, so for London dispersion forces, okay, it is a temporary forces resulted when the electron in two adjacent atom occupy position that make the atom form temporary dipole. Okay, so actually for London dispersion forces, it occur for all types of molecule. Okay, between non-polar molecule. Okay, example between hydrogen molecule, chlorine molecule, methane. Okay, and for London dispersion forces occur also between polar molecules. Okay, so all types of molecule, either polar or non-polar, will have this kind of forces, okay, which is London dispersion forces. Okay, for example, between chlorine molecule, okay, the attractive forces for London dispersion occur when the random movement of the electron in the molecule. So at some point, alright, okay, at some point, the electron density might be higher at one end, okay, than the other. So it will give a temporary dipole. Okay, here. So this is London dispersion occur, which is temporary dipole occur. For dipole-dipole forces, okay, these occur between polar molecules only. Okay. Dipole-dipole forces is attractive forces between the positive end of one polar molecule and the negative end of other polar molecule. Okay. So for example, okay, between HCl molecule. Okay, so HCl is a polar molecule, okay, because partially negative here for chlorine. Okay, so electron share here, form electron cloud. Okay, at negative end here. Okay, so positive end here means that electron poor region. Okay, so between the molecule, another molecule of HCl. So this is the electron poor region part. Okay, so occur forces, okay, between positive end of one polar molecule and negative end of another polar molecule. So it will give attraction, okay, called as dipole-dipole forces. Okay, dipole-dipole forces occur between polar molecules only. Okay, for example, hydrogen sulfide. Okay, so between the molecule is intermolecular forces. Okay, remember. So between partially negative, okay, on sulfur polar molecule with positive end of H atom from another polar molecule. Okay. Same type of molecule, okay, but the forces occur between the molecule, okay, between the negative end and positive end. So it will create a dipole. Okay, same with other example, okay, between negative end from hydrogen chloride from chlorine and positive end from hydrogen. Okay, between polar molecule and then between negative end and positive end. So it will create a dipole, a permanent dipole. Okay, the strength of intermolecular attraction, okay, increasing with the increasing of polarity. Okay, next is hydrogen bond. Okay, hydrogen bond is a special interaction between hydrogen atom in a polar bond with the electronegative atom such as oxygen, nitrogen, chlorine. Okay, it occurs on polar molecule, but that polar molecules has hydrogen atom either contain oxygen atom, nitrogen or fluorine atom. Okay. So, for example, H2O here. Okay, so between H2O molecule, okay, so it exists the hydrogen bond, okay, between hydrogen, okay, and oxygen. Okay, so this is the stronger hydrogen bond compared to dipole-dipole forces and London dispersion forces. Okay, so remember for hydrogen bond, okay, the hydrogen okay, either the interaction of hydrogen between either these three electronegative atom only. Okay, so we look at the this okay, example. For example, between H2O molecule, okay, hydrogen and the interaction towards oxygen, okay, of H2O molecule, okay, between the molecules. Okay, for example, the example in hydrogen fluoride, ammonia, and H2O or water molecule. for hydrogen fluoride, okay, example, so occur interaction, okay, between hydrogen and fluorine, okay, so this is hydrogen bond. Alright, so for each hydrogen fluoride, it can form one hydrogen bond only. Okay, next for ammonia. Okay, between NH3 molecules, so it has interaction between hydrogen and nitrogen, okay, from other NH3 molecules. Okay, so each NH3 molecule will form one hydrogen bond only. Okay, for next for H2O molecule, so okay, so since it has two lone pair, it can form okay, so for one molecule H2O can form two hydrogen bonding. Okay, untuk setiap satu molekul of H2O, okay, dia boleh form dua hydrogen bonding dengan another H2O molecules. Okay, so untuk hydrogen bond, ni tengok molecules tu mesti ada hydrogen dengan either atom, fluorine, oxygen or nitrogen. Okay, okay. Next, the strength of intermolecular forces increase with an increasing in molar mass or molecule size. Okay, so larger atom have larger electron cloud, so it can easy to polarize and create or induce dipole. Okay, the molecular size and mass generally parallel to each other. Okay, so the dispersion forces or intermolecular forces increase in strength with an increasing molecular weight. Okay, so you look at this example. Okay, so in fluorine molecule, okay, until iodine molecule, so the molecular weight is increasing. Okay, same goes to the boiling point is increasing. Okay, so contohnya untuk iodine molecule, okay, has highest boiling point in halogen group. Okay, so means that high energy to break the bonding, okay, between the molecules. Okay, because of the increasing molecular weight, okay, compared to the fluorine, slightly low boiling point. Okay, same goes to this noble gases example. Okay, increasing molecular weight, okay, will increase the strength of intermolecular forces and the boiling point also increase. Okay, this graph show the variation in boiling point of the hydride group of group 14 until group 17. Okay, so when we look at from methane, silane, germanium and tin hydride, here group 14. Okay, so the boiling point increase, okay, with the increasing of molecular mass. Okay, for this one, so that's why the boiling point increase for tin hydride, okay, because highest molecular weight compared to methane. So high energy to break the bonding between molecule of tin hydride compared to intermolecular forces between molecule of methane. Okay, for the result of increasing molecular weight. Okay, next we look at H2O, HF, and NH3. Okay, so these three molecules have abnormal high boiling point. Okay, even though the size, their size is smallest in their respective group. Okay, so this is because for H2O has the highest boiling point compared to HF and NH3. Okay, because each H2O molecule can form two intermolecular hydrogen bond. Okay, so it can form two hydrogen bond. Okay, but for hydrogen fluoride and NH3, it can form one hydrogen bond only. Okay, untuk hydrogen fluoride and ammonia. Okay, but why hydrogen fluoride has higher boiling point compared to NH3? Okay, this is because fluorine has higher electronegativity compared to nitrogen. Okay, so that's why hydrogen fluoride has higher boiling point compared to NH3. Okay, these two molecules, HF and NH3, lower boiling point compared to H2O because they can form only one hydrogen bond. Okay, H2O can form two hydrogen bond. Okay, and the hydrogen bond is the stronger than van der Waals forces. That's why H2O has the highest boiling point compared to the other molecules. Okay. It is the example. Arrange the following compound in the order of increasing strength of the intermolecular forces. Okay, between H2O, CaCl3, NH3, and BeCl2 or beryllium chloride. Okay, if you don't have idea, actually it related. Okay, from Lewis structure and then determine molecular geometry. Okay, from that you have you can know the polarity of molecule, either polar or non-polar. Okay, from the type of molecule, polar or non-polar, you can determine intermolecular forces. Okay, for example, H2O. Okay, H2O is a polar molecule. Okay, and it has polar molecule, and because from the structure, okay, so polar molecule because the dipole moment cannot cancel each other, and this polar molecule can be in the molecule contain hydrogen and oxygen, so it has hydrogen bond. Okay, for CaCl3, okay, when you do this step, okay, you know CaCl3 is polar. Okay, here. Okay, so the dipole towards chlorine which has high electronegative. Okay, here towards carbon. So the molecule is polar. Okay, and then after polar, you know molecule polar, and then you determine the intermolecular forces. So this is polar molecule and contain forces dipole-dipole forces. Okay, is this molecule has hydrogen bond? Okay, kalau hydrogen bond, hydrogen dan melibatkan FON. Okay, tapi molekul ni tak ada atom elektronegatif, so dia polar some other dipole-dipole forces. Okay, saja. Untuk ammonia NH3, okay, polar molecule also, but either contain hydrogen interact with either fluorine, oxygen, nitrogen. Okay, for NH3, okay, yes. Okay, so it has hydrogen bond. Okay, for beryllium chloride. Okay, so when you do Lewis structure and determine the geometry is linear. Okay, and then from the dipole, okay, partially negative, partially positive here. So from the dipole can cancel each other. So zero dipole moment. So the molecule is non-polar. Okay, for non-polar contain London dispersion forces. Okay, so for all polar molecules actually have London dispersion forces, but for H2O and H3, since hydrogen bonds are stronger, so these forces are significant. Okay, so when comparing the forces, so two molecules has hydrogen bond, H2O and H3. So which one is the stronger? So H2O, right? Because it has can form two hydrogen bond compared to NH3 one hydrogen bond only. Okay, so let's check with your answer. Okay, so based on the increasing strength of the intermolecular forces, okay, so H2O has the highest strength of intermolecular forces since it has two hydrogen bond. Okay, dari dua hydrogen bond. Okay, so followed by NH3 polar molecule, but also has hydrogen bond. Only one can form one hydrogen bond only, so less strength compared to H2O. Okay, for CHCl3, okay, polar molecule, but it contains dipole-dipole forces. Okay, dipole-dipole forces less strength compared to hydrogen. Okay, hydrogen bond. Okay, and the lowest strength of intermolecular forces for beryllium chloride, since non-polar molecule, it has London dispersion forces. Okay, the weakest intermolecular forces. Okay, the highest is hydrogen bond and forming two intermolecular hydrogen bond. Okay, so the last one is dative covalent bond. It is a coordinate bond or dative covalent bond, which is a covalent bond, okay, where a shared pair of electrons in which both electrons come from the same atom. Okay, for example, the reaction between ammonia and hydrogen chloride. So, okay, so both of these binding electrons came from the nitrogen atom and forming NH4 plus chlorine minus 1. Okay, so that's all for chapter 4. Thank you.